Hey, we're going to be looking at the tangent ratio. Bum, bum, bum. Big excitement, fanfare. Woo! Now, we have to have a right triangle to perform this type of trigonometry. There's never a choice with hypotenuse. It's always the longest side, and it's the side across from the right angle. Now, there are two acute angles. I have to pick one of them. I chose angle A. Once I choose that angle, I now know which leg is opposite and which leg is adjacent. Opposite has to be all the way across from the angle. Now, don't try to memorize where you think opposite and adjacent belong, because look what happens if I pick angle B instead. Exact same triangle, hypotenuse is in the same place, the right angle is in the same place, the A, B, and C are in the same place. But if I want to study angle B, look where opposite and adjacent end up. They trade places. Also, don't try to memorize what you think a triangle should look like, because the orientation will change. Right? You can't always say, oh, gee, the opposite will be on the left, or oh, gee, the opposite will be on the right, or oh, the opposite will be on the bottom. You don't know where these things are going to show up. You have to pay attention to the diagram. Notice where the right angle is, because that will help you orientate yourself with the hypotenuse, the longest side. It's got to be across from the right angle. Then you have to know which angle you want to study. Once you pick one of the two acute angles, you can assign opposite and adjacent appropriately. Remember, ratio is just a fancy word for fraction. When we work with trigonometry, we're just looking for a fraction. So the tangent of angle A is the ratio of the opposite leg compared to the adjacent leg. This all seems to make a little more sense for students when we actually put some numbers in here instead of just a bunch of letters. Dramatic pause there. Mathematicians would normally want to leave their answer as an exact fraction, but every so often you encounter a scientist. Maybe you're taking a chemistry class or a physics class, and those scientists, holy cow, they love converting the decimals. So we'll do it both ways here. Okay, so for the tangent of S, I need to find the opposite leg and the adjacent leg. The opposite leg has a length of 80. The adjacent leg has a length of 18. Of course, I should reduce the fraction if possible. 80 and 18 are both divisible by the number 2. And then if I grab a calculator, it actually becomes 4.4 repeating. But since the directions ask for 4 decimal places, I rounded it off. Now, exact same triangle, exact same picture. What if we want to study angle R and we want the tangent of angle R? Opposite and adjacent have traded places. ST is now the opposite leg. That has a length of 18. RT is now the adjacent leg, and that has a length of 80. Again, reduce the fraction if possible. And then since the directions ask for decimal, 9 divided by 40 comes out to be exactly 0.225. But since the directions wanted 4 places, I put a 0 after the 5. Well, looking at an angle that's labeled as 32 degrees, 11 is the opposite leg, x is the adjacent leg. Well, if I've got opposite and adjacent, I've got to use tangent. Right? What would be the tangent of 32 degrees for this triangle? Well, tangent is opposite over adjacent. So the tangent of 32 degrees will be 11 over x. Well, we better figure out x. Let's multiply each side by x. Now I've got x times the tangent of 32 degrees equals 11. Well, we're making some progress, but I really want x isolated by itself. Divide each side by a tangent of 32 degrees. Now it becomes a game of, can you push the buttons on a calculator in the correct order? Comes out to be about 17.6. Now notice when I'm working with a calculator, I've got to make sure that I am set in degrees, not radians, and not gradients if you happen to have a calculator that gives you a third option. Most scientific calculators will just have you choose between degrees and radians. Notice I have to communicate with my calculator and make sure it understands that it's 11 divided by the tangent of 32 degrees, right? Not 11 divided by 32. It's 11 divided by the tangent of 32 degrees. Make sure that calculator is in degrees. Figure out how your calculator lets you choose between degrees and radians. If you come across a calculator that has a DRG button, that actually allows choice of degrees, radians, or gradients, you will use degrees in geometry. When you get to pre-calculus, you'll definitely be using radians. We might even touch on those a little bit in Algebra 2. Gradients, I don't know why calculators put them on there. You can get through college calculus and you won't use gradients. Degrees and radians while we're in high school. All right. Triangle ABC has hypotenuse C equals 20 and leg B equals 16. Find tangent A. I wonder what I should do first. Paint a picture, of course. Well, maybe I can't paint a really beautiful picture, but I can draw a triangle. Doesn't have to be a perfect triangle, but try to make it look like it's got a right angle. Remember, we use the capital letters for the angles. Notice the placement of 20. Since lowercase c was 20, lowercase c has to be opposite angle c. Right? For leg B, right, lowercase b, that's the side opposite capital letter B. So that's why 16 got placed all the way across from angle B. So for tangent, I need to be at angle A, and I need to look at the opposite side in comparison to the adjacent side. Uh-oh, we don't know the opposite side. Thank goodness for Pythagoras. I don't know what A is, but I know B is 16. I know C is 20. 16 times 16, of course, is 256. 20 times 20 is 400. I actually need to subtract to get A squared isolated. And of course, if A squared is 144, I need to take the square root. I get 12. Notice this is not like solving an equation. If we were solving an equation, we'd have to think about plus or minus the square root. When we're working with right triangles, we always assume the sides are positive. So with right triangle trigonometry, we assume that all three sides are positive, and so we're not going to have to worry about the plus or minus. Again, tangent is opposite divided by adjacent. So if we're looking at a tangent of angle A, opposite side is 12, adjacent side is 16. And of course, I've got a common factor of 4. Cancel that common factor. Tangent of A is 3/4. Since the directions did not ask for a decimal, I'm just going to stop right there. I'll be a mathematician. Keep it as a fraction. Today's IXL is partially related to this lesson. It doesn't work with tangent, but it does help review ratios and proportions. Remember, whenever we're working with tangent or any other trig function, we're actually looking at a ratio. So the IXL will just kind of refresh you a little bit with ratios, and then we'll move on tomorrow.